Today, we will have a group discussion on classification algorithms. We have Rohan, Zia, Prakriti, Anshul, and Swati here to share their thoughts. Let's start with Rohan. Rohan, can you explain what classification algorithms are?
Sure. Classification algorithms are a type of machine learning algorithm used to assign a category label to a given input data. They are widely used in applications such as email spam detection, medical diagnosis, and image recognition. These algorithms learn from labeled training data and then classify new, unseen data into one of the predefined categories.
Great introduction, Rohan. Zia, why do you think classification algorithms are important?
Classification algorithms are important because they help automate decision-making processes by accurately predicting the category of new data. This automation can save time and resources and improve accuracy in tasks such as fraud detection, customer segmentation, and predictive maintenance. They are essential for turning large volumes of data into actionable insights.
Excellent points, Zia. Prakriti, can you discuss some common types of classification algorithms?
Of course. Some common types of classification algorithms include decision trees, which use a tree-like model of decisions, logistic regression, which predicts the probability of a binary outcome, support vector machines, SVM, which find the best boundary to separate different classes, k-nearest neighbors, KNN, which classify based on the closest training examples, and naive Bayes, which applies Bayes' theorem with strong independence assumptions.
Well said, Prakriti. Anshul, how do these algorithms learn to classify data correctly?
These algorithms learn to classify data by being trained on a labeled dataset where the input data is paired with the correct output category. During training, the algorithm adjusts its parameters to minimize the error in its predictions. For example, in a decision tree, the algorithm splits the data based on features that result in the most homogeneous subgroups. In SVM, it adjusts the boundary to best separate the classes. The goal is to find a model that performs well not only on training data but also on new.
Very true, Anshul. Swati, can you explain the difference between supervised and unsupervised learning in the context of classification?
Sure. In supervised learning, the algorithm is trained on a labeled dataset, which means each training example is paired with the correct output. Classification is a type of supervised learning because it uses labeled data to learn how to classify new inputs. In unsupervised learning, the data is not labeled, and the algorithm tries to identify patterns and groupings in the data without prior knowledge of the correct output. Clustering is an example of unsupervised learning. So, classification relies on supervised learning principles.
Excellent explanation, Swati. Rohan, can you give an example of a real-world application of a classification algorithm?
One real-world example is email spam detection. Email providers use classification algorithms to filter out spam emails from your inbox. The algorithm is trained on a dataset of emails labeled as spam or not spam. It then uses features like the email's content, sender information, and subject line to classify new emails. This helps users by automatically keeping unwanted emails out of their primary inbox.
Great example, Rohan. Zia, can you share some challenges that might be faced when using classification algorithms?
One major challenge is dealing with imbalanced datasets, where one class is much more frequent than others, leading to biased predictions. Another challenge is ensuring the model generalizes well to new data, avoiding overfitting on the training data. Additionally, high-dimensional data can make the classification task more complex, requiring dimensionality reduction techniques. Also, the quality of the labeled data is crucial. Noisy or incorrect labels can significantly impact the model's performance.
Those are significant challenges, Zia. Prakriti, can you suggest some best practices for using classification algorithms effectively?
A good practice is to start with a clear understanding of the problem and the data. Pre-processing the data, like handling missing values and scaling features, is crucial. Using techniques like cross-validation can help ensure the model generalizes well. Feature selection or dimensionality reduction can improve model performance and reduce complexity. Finally, regularly evaluating the model with new data and updating it as needed helps maintain its accuracy and relevance.
Excellent suggestions, Prakriti. Anshul, any final thoughts on the future of classification algorithms?
I think the future of classification algorithms will see more integration with deep learning techniques to handle more complex data, such as images and natural language. As computational power increases, we will see more real-time applications of these algorithms. Additionally, advancements in explainability and transparency of these models will help in gaining trust and understanding of their decisions, especially in critical fields like healthcare and finance.
That's a great perspective, Anshul. Thank you all for your valuable insights on classification algorithms. This concludes our group discussion. I hope you all learned a lot today.